There is an important point. Please note it that whenever all the four temperatures are same, in case of a parallel flow or contour flow heat exchanger, the LMTD of contour flow will always be greater than the LMTD of parallel flow. Please note it. All four temperatures are same. LMTD of contour will always be greater than LMTD of parallel. Please note it. It is an important point. Now let us solve some question. It is GATE 2008 question. GATE 2008 question. In the question it is given that LMTD of a contour flow heat exchanger is 20 degrees Celsius. LMTD is 20 degree. In these questions, always start the question by making the temperature profiles. Please make the temperature profiles. Since it is a contour flow heat exchanger, please make the profiles. The arrowhead should be opposite. In the question, it is given that the cold fluids enter at 20 degree and hot fluid enter at 100 degrees Celsius. So it is 20 degrees Celsius. This is 100 degrees Celsius. Mass flow rate of cold fluid is twice that of hot fluid. Mass flow rate of cold is twice mass. Specific heat at constant pressure of hot fluid is twice that of cold fluid. These two conditions are given in the question. Now let us, from these two conditions, we can see it is clearly we can reduce m dot c cpc is equal to m dot h cph. Since it is counter flow heat exchanger and the conditions of heat capacity are also same, so it is the special case 2 that we have studied. In this case, the LMTD is equal to delta Ti or delta Te. Now let us see what we have to find. The exit temperature of the cold fluid is 40 degree, 60 degree, 80 degree cannot be determined. And you have to find this. Let it be X. LMTD we are given it is 20 degree. LMTD is 20 degrees Celsius. Let us take delta Ti. Delta Ti. Delta Ti's difference is this 100 minus X. 100 minus X 20 X is equal to 100 minus 20 which is equal to 80 degrees Celsius. So we have found out the exit temperature of cold fluid is 80 degrees Celsius, which is one of the option, that is the C option. 80 degrees Celsius. In this case, this temperature is also known, not known. The question is over there. This I am elaborating from my side. We have not been given THE, exit temperature of hot fluid. Let us calculate that by using this. Delta TE is equal to Y this temperature will come out to be equal to 40 degrees Celsius. So it is a very good question. GATE 2008. We have used here case 2. In case 2, clearly see it is a counterflow heat exchanger, and the heat capacities of cold and hot fluids are same. GATE 2008. Now let us do another question. GATE 2011, 2 marks question. In the question it is given cold water flowing at 0.1 kg per second is heated from 20 to 70 in counterflow heat exchanger. So again it is counterflow. How to start this problem? I told you, meet temperature profiles, counterflow. These are parabolic. It is given is cold water is heated from 20 to 70 degree. 20 degree to 70 degree. And they have given mass flow rate is 0.1 kg per second. Then they have given it is heat exchanger by a hot water stream flowing at 0.1 kg per second and entry at 90 degrees Celsius. This is 90 degrees Celsius and m dot 1 kg per second. These two are same. Then they have given us Cp of water and its density. Density is also given, but we do not need. Overall heat transfer coefficient is given 2000 watt per meter square Kelvin. We have to calculate area of the heat exchanger. 4 options are given and we have to calculate area of the heat exchanger. Now let's see how to proceed. In this case, it is counterflow heat exchanger and m dot HCP is also equal to m dot CCP. CP will be taking this, m dot is same. So both the conditions are being satisfied. So we can see from case 2 that LMTD will come equal to the difference between these two or the difference between these two. This temperature is not given to us and this temperature is given, so LMTD will be equal to 90 minus 70, which is equal to 20 degrees Celsius. You can understand LMTD. We have used case 2, LMTD is 20 degrees Celsius. Now we have to found LMTD. We are knowing U, and we have to find out Q, so that we can use U is equal to UA delta Tn. This we are knowing. This we are knowing. These two we are knowing. This we have to find out. This we have to find out again by using these conditions. U can also be find out by using U is equal to m dot Cp delta T, 0.1 into 70 minus 2050 Cp 4200. The answer is 21,000. 21,000 is the answer. So now let's substitute. A is equal to Q divided by U delta Q divided by U delta Tn. by substituting these we will get value. This is the area of heat exchanger. See the method that we have used. We have used case second. First draw this diagram, temperature profiles in every question of heat exchanger. Then see which case is being applied, case 1, 2, or we have to proceed by different method. Then we have to calculate LMTD we have calculated. Then we have calculated Q by using m dot Cp in delta T. These two temperature are given. We have calculated this, we have substituted all the things in this formula, and we have got area. Please note